So we already know that when we're trying to solve an equation with trig expressions, if we're meant to do it by hand, then there's got to be a way to get the trig functions isolated. In this very first problem, I have a sine of 2x and a sine of x. These are not like terms, and there's no way to really isolate one versus the other. This is where we're going to bust out this identity. I can replace this sine of 2x with an alternative form. I can say this is equal to the 2 times the sine of x times the cosine of x. And then, of course, I have minus sine of x equals 0. Yay! This looks a lot like a problem that I know how to solve. I can look at these two terms and factor out the common factor of sine of x, leaving me with 2 times the cosine of x minus 1. And then we've done these problems many times. So if you know from here that the answer is going to be 0 plus pi n, and pi over 3 plus 2 pi n, and 5 pi over 3 plus 2 pi n, you don't need to watch the rest of this video. But if you don't know that, here's what happens next. I have to figure out when the sine of x equals 0. And I have to figure out when 2 times the cosine of x minus 1 equals 0. And then I need to think about my fun unit circle. I throw the word fun in there to throw you off. You're like, oh yeah, it's fun. This is the vertical component, and it should be 0. That puts it here and here. So x is either equal to 0 or pi, or 2 pi, but I'm not going to include 2 pi's. This guy, if I add 1 to both sides and divide by 2, I can see that cosine of x equals 1/2. So I draw my picture in my head. Worst drawing ever. But these are pi over 3 reference angles. So my other answer would be pi over 3. That's what this one is. And then this goes almost all the way around, but it stops pi over 3 short of 2 pi. I need to think of 2 pi as being 6 pi over 3, and pi over 3 less than that is 5 pi over 3. And those are my answers. But how did the double angle come in again? I started off with two things I couldn't combine and they weren't alike, but I could replace sine of 2x with this expression, and that allowed me to do some work that I know how to do. We'll try question 2 in a separate video.